Next, in the topic, one more topic is there, that is factors favorable for the formation of an. In previous video, we discussed factors favorable for the formation of cation. Now, we will discuss about factors favorable for the formation of anion. In case of cation, what is the first condition? Large atomic size. But here, first condition is small atomic size. Because how anion is formed? When an electron is added to neutral atom, then anion will be formed. We know that. Because we discussed that point in case of electron affinity. Then which atoms readily forms anion? Which atoms means large sized atoms or small sized atoms? Small sized atoms. Because when the atomic size increases, electron affinity decreases. We discussed that point. That means atom size should be low. Then formation of anion easily. So what is the point here? Atomic size is less, then it has tendency to gain electrons, and formation of anion increases. For example, take nitrogen atom, oxygen atom, fluorine atom. All these are atoms present in same period. In that period, which is having less size? Fluorine has less size, because from left to right atomic size decreases. So fluorine has less size compared to oxygen, which is having less size compared to nitrogen. That means nitrogen having more size among these three cases. But which is readily to form anion? Fluorine, because of less size. So order is what? Nitrogen less than oxygen less than fluorine. This is which order? Formation of anion order. Which can form anion easily? Fluorine can form anion easily. That is the first factor. Next, second factor. In cation case, what is second factor? Low IP. In this case, high EA or EN. Because in both electron affinity and electron negativity, which is what is the favorable condition? If size of the atom is less, electron affinity, electron negativity both are increases. So if an atom has more electron negativity, then it readily forms anion. Then again same example. Next, in third case, in that case, in cation case, what is the third case? Low charge. Here also third case is low charge, because see, n minus 3 O minus 2 F minus, n minus 3 O minus 2 F minus. In which case charge is very less? In this case, because here charge is minus 1, here minus 2, here minus 3. So my point is what? In this case anion formation easily. Why? Because as the negative charge increases, size of the species increases, size of the ion increases. As the positive charge increases, size of the cation decreases. But as the negative charge increases, size of the ion increases. If the size of the ion increases, then anion formation decreases. So that if ion having, which ion? If anion having low charge, then formation of anion increases, then formation of ionic bond also increases. As the charge on the ion decreases, charge on the ion, which ion? Anion decreases, then the size of the ion decreases. Hence anion formation increases. So what is the order regarding n minus 3 O minus 2 F minus? This is having more anion formation compared to O minus 2. This is having more anion formation compared to n minus 3. So these are the three factors which are favorable for the formation of anion. What are they? Small atomic size, high electron affinity, and low charge on anion. In case of cations, what are the factors? Large atomic size, low IP, low charge on cations with inert gas configuration. Now these conditions, which conditions, factors favorable for the formation of cation and factors favorable for the formation of anion, these are called Fajans rules. These are called what? Fajans rules. Now we will discuss Fajans rules. That means factors favorable. Fajans rules means factors favorable for the formation of ionic bond. That means when we discuss about these two, that will come under Fajans rule. If we discuss Fajans rules regarding formation of ionic bond, then the exact opposite rules comes under formation of covalent bond. Now we know the rules for the formation of ionic bond. What are the rules? Cation has large atomic size and anion has small atomic size. That is the first rule. Here second rule, cation has low IP and anion has IEN. Cation has low IP and anion has IN. This is second rule for formation of ionic bond. Next, third one, both cation and anion have low charge. Both are having low charge. And fourth point, cation with inert gas configuration. So these are the four rules which are favorable for the formation of ionic bond. Now exactly opposite rules which are favorable for formation of covalent bond. They are what? Cation has large size. Here cation has a small size. Here anion has small atomic size. Here anion has large atomic size. Next, here cation has low IP, but here cation has high IP. Here anion has IN, but here anion has low EN. Next, both cation and anion have low charge, but here both cation and anion have high charge. Next, here cation with inert gas configuration favorable for the formation of ionic bond, but here cation with pseudo inert gas configuration favorable for the formation of covalent bond. So these are what? Fajans rules. Next, here some examples are there. See, they are NaCl, MgCl2, AlCl3. That means in these three cases, which is having more ionic character? That means in which case ionic bond, more ionic nature is there. That is our point. In which case less ionic nature is there. See, NaCl, MgCl2, AlCl3. What we have to think here? In those three cases, anion is chlorine. See here, NaClCl, MgCl2Cl, AlCl3Cl. That means anion is same. So forget about anion, because in all these cases anion is same. But cations are different. In this case, cation is Na plus. In this case, cation is Mg plus 2. In this case, cation is Al plus 3. Now our target is what? In which case ionic character is more? Ionic character is more. In which case? In this case, because here Na plus, here Mg plus 2, Al plus 3. If cation having low charge, then in that case cation formation increases and ionic bond formation increases. Automatically NaCl having more ionic nature than MgCl2 than AlCl3. You have to think like that. Next, one more example. LiF, LiCl, LiBr, Lii. In all four cases, cation is Li plus. So forget about Li plus. We have to see anion. Here anion is F minus, here Cl minus, here Br minus, here I minus. All these ions are present in same group: fluorine, chlorine, bromine, iodine. All these are present in same group. These are present in 7A group. ORR, these are present in 17th group. In those ions, which ion? This is anion. For anion, which is the favorable condition for formation of ionic bond? Anion should have low size. So in all those cases, which ion has low size? F minus, because F minus is the topper element in 17th group elements. Iodide is the bottom element in 17th group elements. That means from top to bottom size increases, so that F is having low size and iodine having less size. If the size of the anion decreases, formation of ionic bond increases. So that in that case, in which case LiF has more ionic nature compared to LiCl, which is having more ionic nature compared to LiBr, which is having more ionic nature compared to LiI. Next, covalent bond. That means exactly opposite. Say in those three cases, this is having more ionic nature, automatically it is having less covalent nature. This is having less ionic nature, automatically it is having more covalent nature. In second case, this is having more ionic nature, automatically it is having less covalent nature. This is having less ionic nature here, but here it is more covalent nature. So if you know about ionic bond, then automatically you will get clear idea about covalent bond, because the rules are exactly opposite. Those rules are called what? Fajans rules. Next, properties of ionic compounds. Properties. All ionic compounds present in solid state because of strong electrostatic force of attractions. Next, they have high melting point and boiling point due to strong electrostatic force of attractions. Next, ionic compounds are readily soluble in water due to hydration. I will discuss this point here. Hydration means, suppose, see, take NaCl. When this NaCl present in water, then immediately NaCl undergoes dissociation like Na plus and Cl minus. After dissociation, this Na plus surrounded by water molecules. Similarly, Cl minus also surrounded by water molecules. Between these water molecules and ions, some forces are exist. Here that forces are called hydration energy. Hydration energy. That phenomenon is called hydration. Because of this hydration energy or hydration, the solubility of substances increases. I repeat once again, when any ionic compound present in water, then it undergoes dissociation. After dissociation, these water molecules surrounded by ion, these ions surrounded by water molecules, then between water molecules and ions some forces exist. Those forces are called hydration energy, and that phenomenon is called hydration. Because of hydration, solubility increases. So here point is what? Ionic compounds are readily soluble in water due to hydration. Next, ionic compounds do not exhibit conductivity in solid state, but they exhibit conductivity in molten state or in fused state. This is very, very important point. Ionic compounds do not exhibit in conductivity. Suppose take sodium chloride. When it is in solid state, when we pass electricity to that sodium chloride, if you touch that sodium chloride, you will not get any electrical shock, because in that sodium chloride, Na plus Cl minus ions are present, but those are not free. Those are attracted by strong electrostatic force of attractions. But when that sodium chloride present in water, if you apply electricity to that water, if you touch that water, immediately you will get electrical shock, because when sodium chloride present in water, then immediately that sodium chloride undergoes dissociation, then free ions are produced. They are Na plus and Cl minus. If free ions are present, then that substance exhibit conductivity. So what is our point? All ionic compounds do not exhibit conductivity in solid state, but they exhibit conductivity in molten state or in fused state or in aqueous state. Aqueous state means when any substance present in water, that is called aqueous state. Then what about molten state? When you heat that, when you heat any substance, then that substance, that any solid substance, then that solid substance converted into liquid state. That liquid state substance is called molten state or fused state. So both are same meaning, molten, fused. So what is the meaning of aqueous state? When any substance is present in water, that is aqueous state. When we heat any substance, any solid substance, if it is converted into liquid state, then that state is called what? Molten state or fused state. So our point is what? All ionic compounds do not exhibit conductivity in solid state, but they exhibit conductivity in molten state or fused state or aqueous state. So this is very important point. You may get one more question regarding this topic. That is what? Why NaCl acts as bad conductor in solid state? What is the reason? In solid state, there is no free ions between Na plus and Cl minus. There is no free ions in NaCl, so that it does not exhibit conductivity. That's all. That means single line answer. So this is all about formation of ionic bond, Fajans rules, and properties of ionic bond. Thank you.